So now we'll quickly go through class 11 and 12 physics formulas. Okay, I have written this one. What you see in the board is class 11. You have one book on the motion and Newton law and all. This is the other one. Okay, here we have the fluids, and we have the thermodynamics, and we have the oscillations, and we have the velocity of sound wave and all that. So most of the things I have written here: surface tension, velocity, so and the fluids, the Bernoulli's equation, the equation of continuity. So let us start with oscillations. Okay. So oscillations, we said force is equal to mass into acceleration, and the displacement is x is equal to a sin omega t. This is for simple harmonic motion. So first derivative of displacement is velocity, which is which is omega a cos omega t. Okay, then x double dot is equal to minus omega square a sin omega t. So a sin omega t you can replace as x. So it becomes your acceleration becomes minus omega square x. Okay. So f is equal to again kx also. So one is your inertia force, one is your restoring force of a spring. So when you compare this equation with this equation, okay, so you can see that when you compare these two terms, x same, m omega square is equal to k. Okay, one is m omega square s, one is kx. Okay, so I have not used it now. I am just saying m omega square x is your force. So how I got m omega square x? Because x double dot is equal to omega square x. Yeah. Okay. So m omega square x, by replacing acceleration as omega square x, I got m omega square x. Now I am comparing these two, and I am finding omega equal to k square root of k. That is your angular frequency, which is unit is radian per second. Yeah. That you have to remember. Okay. So if my angular frequency is equal to 2 pi by t. So that means which is equal to k by n. So time period is equal to 2 pi square root k by n. Okay. Then frequency is equal to 1 by reverse of that. Okay. So this is you can get a numerical on this for sure, because so just remember omega is equal to square root k by m. So k for omega, just start with omega, then you will go to frequency. Yeah. So for omega, spring constant will be there in the numerator. Yeah. Okay. So if you see that if you want to verify also omega, it will be per second. Okay. So if you do k by m square root, it will be second square, 1 by second square. Okay. Newton per meter. Okay. Newton per meter, and this is kg. So this will be kg. So kg meter per second square, and then this will be kg. Okay. No. So k by m, k is nothing but your Newton per meter. Okay. Okay, and mass is equal to your kg, right?
Newton kg inverse meter.
So kg, this is kg per second square, right? Yeah. Because meter cancels, so it will be second. So if you have any doubt, you can verify immediately. Yeah. So omega is equal to k by m. With that it starts. Okay. Yeah. So k will be in the numerator. That is omega. Frequency will just be reversed. Yeah. Okay. So then this is the frequency. So t is equal to k by m. So time period related to omega, right? Yeah. Time period related to omega. So 2 pi k by m. Yeah. And then reverse of time period is your frequency. Yeah. The frequency unit is per second. Okay. Omega unit is radian per second. Okay. Means number of oscillations per second. That is frequency. Okay. So omega is k by m. That is the from there you can start. Okay. And then you have some numericals we have seen in the paper. That is the total energy. So this you can see a curve. Okay. So this blue one is your potential energy. This red one is your kinetic energy. So this is your mean position. So this is at 0. Let us say this is this, and this is at the end it is A, and at the end it is A. Okay. So at the extreme position, as I was telling, like if you think about the pendulum, at the extreme position it will be at the maximum height. That means at the extreme position always potential energy will be maximum. and at the mean position kinetic energy will be maximum. So this red one is your kinetic energy.
Yeah.
Okay. So then how do I derive the equation? So kinetic energy is equal to half mv square. Then we have derived x. Yeah. So here there is, this is x dot. Okay. So x
Yeah.
dot. Okay. Sorry. No, x equal to S. So this is x dot. So that instead of v you put omega a cos omega t. Okay. So if you put, it will become half m omega square a square cos square omega t. And if you see the potential energy, half k square sin square omega t. So one is k square cos square omega t, one is sin square omega t. Total energy is equal to half k square.
Yeah.
So suppose you want to find the energy at let us say somewhere x is equal to a by 2. So there what you can do, like say half kx square. Okay. So that is potential energy. Okay. This is potential energy. So at x is equal to a by 2, this will become half k into a by 2 whole square. Okay. So this will become your potential energy. Then what will be the kinetic energy? Total energy minus
Half
potential.
K
So half k square is the total energy. So once you know potential, you can find kinetic. Okay. So using that principle, you can do good number of numericals. Okay. So okay, and then there is this spring mass system.
In
Okay.
series.
So if you see something like this, it is series.
Yeah.
Sorry, if you something like this is parallel. So it is, this parallel is same as resistors in series. Okay. So the effective your effective stiffness will be K equivalent. It is same as springs in parallel is equal to resistors in series. So the equivalent stiffness is equal to K1 plus K2.
Yeah.
Okay. So here the displacement is remaining the same.
Yeah.
Okay. Like in a series circuit, so springs in parallel is equal to strings in parallel is same as resistors in series. So when resistors in series, that means the current is same.
Yeah.
Okay. Similarly here the displacement is same. Means if you are moving it by x, it is getting stretched by x, then it is minus delta x and it will get stretched by plus delta x. So the displacement of both these springs are same. That's why it will be so displacement. Your displacement is equivalent to your current in electrical, and your force is equivalent to your voltage in electrical. Okay.
Yeah.
So using this principle, if you see some spring mass system like this, you can say the total equivalent resistance is equal to just
K1 plus
resistors in series, which is K1 plus K2, and if both the stiffness are equal, it will be 2K. Okay, so for frequency m by K, K will be replaced by 2K for this system, what I am showing. Okay.
Yeah.
Clear? So now most of the oscillations we have covered. Now then, what else is there? Okay, so Bernoulli's equation. Okay, so just remember Bernoulli equation. You will try to write everything in pressure format. Okay. So you know pressure. One is pressure energy. This is the potential energy. So that is rho gh. So you know pressure formula is rho gh. So pressure and rho gh, that you know. One is pressure, one is rho gh. This you know. Then just another additional form, which is the kinetic energy, that will be rho v square. So between point 1 and point 2, P1 plus half rho v1 square plus rho gh square is equal to P2 plus half rho v. So that is the Bernoulli equation. Using that equation, you can solve any numerical. Okay, and there is, when we solve Bernoulli equation, sometimes we have to use the equation of continuity also. So A1 B1 is equal to A2 B2. That is your equation of continuity. Okay. Then recently we are discussing about surface tension. Okay. So surface tension is nothing but force per unit length. Okay. Or work done per area. So work by area or force per length, that is surface tension. So if someone asks you the dimension of surface tension, or this is nothing but Newton per meter. Newton per meter or joule per meter square. Yeah. So that is the surface tension. And there will be some questions on the extra pressure inside water bubble or a soap bubble. That formula just you have to remember.
2s by
That is 2s by r or 4s by r. S is nothing but the surface tension of water or surface tension of soap. That is a property. Surface tension is a property. It depends on the type of material. Like I say, mercury, it has a very high surface tension. Okay, and surface tension decreases with increasing temperature. Okay, so that's why that hot items it will weight the surface more. So it will spread over your tongue more. That's why it will be tasty. So mercury has with temperature surface tension decreases. So if surface tension decreases, it will try to spread more, right? So that's why the taste is more. So with increase in temperature, surface tension decreases. Also, it is a property. Mercury has high surface tension. Okay. That's why it is not wetting the surface. Okay. So that is about surface tension formula. 2s by r or 4s r. 4s by r is for soap bubble. Okay. Then your capillary rise.
2s cos theta.
So this you have to remember. 2s cos theta by radius. A is nothing but your radius. So if you know surface tension and if you know angle of contact, so there is if you know the angle of contact and surface tension,
you can find capillary.
That is the capillary rise formula. Just 2s cos theta by A. Okay. So then viscosity. Okay. So what is viscosity? So you know shear modulus of rigidity. Okay. Modulus of rigidity is nothing but shear stress by shear strain. Here, instead of writing, so in viscosity, A by A is nothing but shear stress. But shear strain, instead of shear strain, we write it as strain rate. Okay. So instead of writing it as by x by L, we write it as velocity by L. So it is not strain, instead it is strain rate. Okay. So earlier strain did not have any unit. But now because it is strain rate, you will have a second here. So unit of viscosity, coefficient of viscosity is nothing but Pascal per second. Unit of viscosity is Pascal per second. Just remember, not Pascal, Pascal per second. So that is shear stress divided by strain rate, not strain. Okay. So that is one. And that is viscosity. Then another thing is the Stokes Law. Okay. Stokes Law, the viscous force exerted on a ball which is falling freely through a liquid is equal to 6 pi into the coefficient of viscosity into the radius of the ball and the terminal velocity. So you just remember that the resistance force or the viscous force depend on coefficient of viscosity. Higher is the radius of the ball, more is the force. And higher is the terminal velocity, more is the force. What is terminal velocity? When slowly it start moving at a constant velocity. So initially, because of acceleration due to gravity, it will try to accelerate, but there will be resistive force. When they balance each other, you will know you don't have any net force. That time it will start moving at terminal velocity. Okay, so that is one. And then recently we are studying about the velocity. So velocity of transverse wave in a straight string is equal to v square root t by nu. Okay. So nu is mass per unit length. Okay. So that is transverse wave. Similarly, velocity of sound wave. Okay. So velocity of sound wave is equal to gamma Young's modulus by rho square root. Okay. So there can be a number of numerical. Okay. It depends on the Young's modulus. It depends on the density. Okay. So if a material has higher Young's modulus, through it sound will travel at faster. If it has a lesser density, it will travel faster. Okay. So and then velocity that is through solid. Okay. Through air, it is bulk modulus divided by density square root, which otherwise can be written as gamma p by rho, not p by rho, gamma p by rho, because it is a adiabatic process. So this is the equation for velocity of sound, which is a longitudinal wave through air.
Transverse wave.
This one is transverse wave. Okay, this string thing is transverse wave. Velocity is longitudinal wave. So it will be alternate compression and rarefication kind of. Okay. So that is gamma p by rho. And for solid it is Young's modulus by rho square root. Okay, so that is about velocity of sound. Okay, then we are doing Doppler effect.
Apparent frequency.
So Doppler effect, this nu, which is the apparent frequency, is equal to the original frequency
1 into 1
into 1 minus Vs by B. So here V is your velocity of sound, you have to remember.
Yeah.
Where Vs is the speed of velocity of the source of noise. Okay. So
No, Vs is speed of source, V is speed of air. Or speed of
Vs
sound in air. Vs is speed of source.
no, that's what I am telling. Vs is speed of source. V is velocity of sound, right?
तो मैं उल्टा
Okay. Okay. So V denominator is velocity of sound. Okay.
in air.
In air. So normally it is 332 or
332.
whatever. Okay. So I think it is there. Right?
331.
Okay. So that is the.
That
so,
will be given what you're supposed to take V as.
Okay. Okay, you can verify that. It is Vs by V. V is velocity of sound. Vs is velocity of source. Okay. So when something is coming closer to you, your apparent frequency will increase.
Yeah.
Okay. V0 is your original frequency. Okay. Okay. Then we are studying about the harmonics. Okay. So if you have an open pipe, your fast harmonic is nothing but a frequency.
Yeah.
Okay.
Both ends.
In harmonic means what? At what frequency? In fast harmonic it is going to vibrate. Okay. So your frequency of fast harmonic is equal to V by 2L. Okay. And for this also holds good for straight strings fixed at both ends. It is same.
Yeah.
But if you have an open pipe, then it will be V by 4L. Okay. So the L is nothing but length of
This
pipe.
both for first harmonic. If it becomes second,
Both
third, N into V by 4L.
Second harmonic, N is equal to 1, 2, 3, like that.
N into
So we have
V by 4L for open.
Yeah. So they will ask, okay, whether they will give a frequency, okay, whether it will be some harmonic that you have to find out. Okay, they may ask you which harmonic it is. So if you find the first harmonic, then if you know the frequency, then you can find out which frequency.
If harmonic is given, you can find the frequency.
Yeah. So
that's it.
So that's it for your class 11, the part 2 book.
Yeah.
Okay. So I'll just another 15 minutes. I'll tell you the transmission wave. One simple formula is there. Okay. Class 12 part 2. Okay. I am rubbing it. Okay. You take a picture. I'll rub it. Okay. You see, now we have covered almost everything, so just we have remembered the formula. If you remember the formula, that is enough. Okay. So this transmission of wave we have not studied completely. This transmission of wave I thought. Okay. It is. Okay, so we see some numerical. Okay, so suppose my
communication system
Huh?
communication
system is not coming.
NCRT full JE रे भी delete
Communication system. No? Okay, fine. Then you know this
semiconductor I can do. Yeah.
AND gate, OR gate, all that you know.
And then nuclei dual nature, that energy and all I know.
Okay. So you have NOT gate, OR gate, AND gate. You want to
gates revise.
So logic gates. Okay. Logic gate. Okay. So you have different types of gate. NOT gate, OR gate, NOT, OR, then comes AND. So these are different devices used in digital electronics. Okay, you just say that just binary. Okay, when you want to give a binary output. Okay, you have some input. You want your output to be also binary. So in that case, these gates are used. So AND gate, NAND gate, Means NAND means what? Whatever is the output of AND, just
Not
reverse it. Okay. So that is called NAND gate. Then NOR gate. Okay. So NOR means whatever is the output of OR, just put a this thing. Okay. So if I give you example of NAND gate. Okay. NAND. So what happens in NAND? So let us say you have, okay, so let us say you have two inputs, okay. So let us say this is my A, this is my B, and let us say this is my Y output, okay. So so your, okay, so okay, so this is A, this is B, this is Y, this is in, this is out, okay.
Yeah.
So if this is the case, then this is first you have to see AND, okay. So AND condition is satisfied if suppose this is 0, this is 0, then AND condition will be 0, 0, it will be 0, okay. 0, 1, this is 0, 1, 0, this is 0, only 1, 1, if both are satisfied then it will be. Okay, so these are the output of a AND gate, okay. Then NAND means what will happen?
Opposite of
This will be opposite. So this is 1, right?
All will be 1, only 1.
So 0, 1 is 1, okay. 1, 0 is 1, okay. Only 1, 1 which is 1, this will be 0. So this is the meaning of NAND gate, okay. So similarly now you can understand everything else,
I know,
okay.
I know.
So that is the, like, with given input, what will be the output. So mostly this will be so these things you need to understand, okay. And okay, fine. Then I'll just write down the formulas of for alternating current in 5 minutes. Just
I know.
okay, but there are some oscillations and all. I'll just write. Okay.
1 by 2 pi.
In 2 minutes, I'm just writing down. Okay, for your memory. Okay. Okay, I think here it is there. So in a purely resistive circuit, current and voltage are in phase, okay. And in a pure alternating current purely resistive, I mean is equal to Vm by R, right?
Yeah.
And your RMS is equal to Vrms by R. So I mean means it is not it's max actually. I max or B max, okay.
Yeah.
There is the difference between RMS and B max. So
B max is equal to root 2
so
times.
your household voltage 220 volt is your RMS value, okay. Then what is the max value? 220 volt into root 2. That is your V max. Okay, so if you know V max, you can find out current in resistive circuit. They are in phase. Okay.
Yeah.
So in capacitive circuit, your current is equal to, and this is capacitive. Okay. In capacitive, your current is equal to V max by 1 by omega c. Just remember, this is xc, V max by xc, which is nothing but V max by 1 by omega c. Just this is called capacitive reactance.
Yeah.
Sorry, this is called capacitive reactance. 1 by omega c. That you have to remember. Okay. And in a capacitive circuit, voltage lags. Okay. So if this is your current, this is your voltage.
Yeah.
Voltage is lagging. So this is for capacitive circuit, and then x is equal to 1 by omega c. Okay. Then coming to inductive circuit.
Omega. V max.
Okay. Okay. Okay, I think he has not given, but in inductive circuit, inductive I is equal to V max by
Omega L.
omega L, which is equal to V max by
Omega
omega
L. XL
L.
is equal to omega L.
So that is, this is XL is equal to omega L. Okay, and the current will be, if this is the current, your voltage will be like this. So this is voltage, this is voltage. Because this is for inductive circuit. And for AC supply, the current is the power consumed is equal to, in AC, power consumed is equal to Vrms into Irms into cos phi.
Cos phi is power factor.
Cos phi is
Power factor.
power factor. Okay. So because the in capacitive or inductive circuit, and there is a 90-degree lag. That's why it is called wattless current. Okay. Then
In inductive and capacitive, power factor is 0.
in inductive and capacitive, power factor is 0. Okay. So yeah. So the phase angle. Okay. The phase angle. Suppose
Tan
you.
inverse XL minus X.
So the phase angle, suppose you have a AC circuit, you have a inductance, you have a capacitance, then your phase angle is equal to tan inverse
XL minus X.
XL minus XC by R. Okay, so this is your phase angle. Okay, that is the formula for phase angle. And then there is some phenomena called resonance in LRC circuit. So this is your
And
LRC
omega
circuit.
L is equal to omega L.
LRC circuit. So and yeah, so that the
Omega is equal to
resonating frequency
1
omega
by
is equal
root
to
LC.
1 by square root LC. So that is the resonant frequency. That also, that kind of question can come. Okay. Okay. So then.
LCR.
This is LCR only. Okay. And then
Impedance.
yeah. So impedance is nothing but your R square plus
XL minus XC whole square.
plus XL minus XC
Whole square. Square.
whole square root. Okay. So this is your impedance of a LRC circuit. Okay. And
Oscillator frequency.
yes.
1 by 2 pi LC. Root of LC.
So in inductive circuit, inductive circuit we have already told what is the
Reactance.
reactance. Okay. And then
Quality factor and all.
okay, so then we have a something called LC oscillator. Okay. So if we have a inductor and we have a capacitor, so it will start oscillating. So there is a similarity between spring and this. So if in SC oscillator, this oscillator frequency is also the same as resonance frequency 1 by LC. This also we need to remember. Okay. So these are the major formulas, okay, in AC circuit that you will be using. So this is all about alternating current. Okay. And then for transformer, you know, like secondary voltage by primary voltage is equal to number of turns in secondary, number of turns in primary. That is for transformer. Okay. So yeah, so that is about AC. Okay. You can take a picture of this. And then I am just reminding you about the gravitation. Okay, you might have forgotten. So the gravitation formula. Okay. Okay. Just two formula. So when you go up and when you go down, you know Gm1 and 2 by R square. Okay, and then okay. So effect of altitude. Okay.
2 plus R.
So when you go down, okay. So when you go down your G, so G is equal, so you know G is equal to Gm by R square normally,
Yeah.
right?
Yeah.
So when you go up, G inside R, okay. When you go inside, it will be
One.
yeah. So G into 1 minus D by
Right.
D by
Inside
RE.
R.
This is your radius of R. Okay. So
Outside it is
this
G
is inside R. So if you move depth D inside R, that is the formula. Then G at a height H.
G into 1 minus 2.
So G
2
outside
H by R.
that is G into 1 plus
1 plus 2 H by R.
2H by R. So this, if you remember, that should be okay. And then there is something called orbital velocity. Okay, orbital velocity is nothing but GRE.
Yeah.
Okay. So this is GRE, and there is something called escape velocity. That is yeah, orbital velocity. I think that escape velocity is 2 GRE. 2
Yeah,
GRE.
2 times that.
Square root 2 GRE. So this is orbital and this is escape
Escape
velocity. Okay. And gravitation this is, and then comes region. Okay. Optics anyway you are doing on your own. I have not taught you optics. Then resistance in series and all.
I've learned current electricity,
Yeah.
magnetism.
And then we'll do one numerical on your thermodynamics quickly. So one second. Okay. So thermodynamics, there is some simple problem. Okay, so if you get a diagram like this, okay, so this is PV diagram. If you have a triangle like this, 1, 2, 3, okay, so if it is like this, they will ask what is the work done. So work done is nothing but area under this curve, okay, and one simple problem is given on to find out the COP of a refrigerator, okay. The question is a refrigerator is to maintain eatables kept at 9 degrees centigrade. So you have this refrigerator, your eatables are at 9 degrees centigrade, which is nothing but 281 Kelvin, right?
Yeah.
Okay. And then the room temperature is 36 degrees centigrade. Outside is 36 degrees centigrade, okay, which is equal to 273 plus 36. How much it is?
309.
309, okay, Kelvin. So the question is what is the coefficient of performance? So coefficient of performance we have done that Q2 by W, right?
Yeah.
Q2 by W. So which is nothing but T2 by T1 minus T2.
Yeah.
Right? So this is 309 divided by 309 minus 270. So this is how you find coefficient of refrigerator for a heat engine. It will be 1 minus T2 by T1. That is the efficiency. So now you know what is efficiency and what is coefficient.
Yeah.
Okay. So that's all. I think we have covered most of the things. Okay. This optics and all you can refer on. Okay.